55, 14.4 to 14.5 integrated review. So in this lecture video, let's take a look at simplifying expression using quotient rules. Alright, so what is so-called the quotient rule for exponent says for any real number a, m, and n, alright, so if I have a base a to the m power divided by the same base with a different exponent, okay, when the base are the same and the base are dividing, then we will subtract the exponent. And the way we subtract the exponent is always take the top exponent and subtract the bottom one. Alright, so when the base are the same and the base are dividing, we will subtract the exponent. So why do we subtract exponent? So here I've got a little bit of example, a small example, 2 to the 4th over 2 to the 3rd. So remember now, 2 to the 4th means 2 times itself 4 times, divided by 2 to the 3rd means 2 times itself 3 times. So when you see all these 2's on the top and bottom all being multiplied, you cannot help yourself but reduce top 2's with the bottom 2's. So in that case, when all the 2's cancels out, the only two left is the one on the top. So the subtraction actually representing top and bottom being cancels out. So a lot of times I will simply say I got 4 2 on top, 3 2 in the bottom. Okay, when they are dividing, okay, then when the base are the same and they are dividing, we will simply subtract, okay, subtract the exponent by simply cancel them out, them 2's. So 4 2 on top, 3 2 in the bottom. When they cancel out, how many 2's are left? There should be 1 2 left on the top because the top has 1 extra 2 compared to the bottom. So if I will flip this problem around, let's say for example 2 to the 3rd over 2 to the 4th. So here I got 3 2's on top being multiplied and 4 of them in the bottom being multiplied. So when the top and bottom canceled out, there should be 1 2 left in the bottom. So when there's nothing on top, that means all the 2's being canceled out. So as you can recall, when we reduce in fractions and when everything canceled out, there should be a 1 left. So that would just simply be a half. So if you just say 2 times 2 times 2 over 2 times itself 4 times, okay, when top and bottom cancels out, that all becomes 1. So the only thing you have left on top is just 1 times 1 times 1 times 1, which is 1. Alright, so let's try this problem real quick. 2 to the 9 power divided by 2 to the 7 power. That means I got 9 2's being multiplied on top over 7 of them in the bottom being multiplied. So when all these 2's cancels out, that means I'm subtracting the exponent, then I should have 2 more 2's left on the top. And we know 2 squared will be 4. Okay, you gotta enter numerical answer on the homework. Alright, x to the 8 over x to the 5th power. So I got 8x on top, 5 of them in the bottom. When all the x's cancel out, how many x's should be left? You should have 3 of them left on the top. So that will be x times x times x, which is x to the 3rd. Subtract the exponent. Top subtracts the bottom. Alright, so when there are coefficient in front, sometimes we can go ahead and take care of those ahead of time. Negative 15 divided by negative 3, that should give me a positive 5. Alright, be very careful now. When we write this positive 5, that positive 5 is referring to 5 over 1. So that instantly puts a 5 on the top. So here I got 3y on top, 1y in the bottom being multiplied. So when they canceled out, there should be 2y left on the top. Okay, so 5y squared would be my answer. So just quickly, for example, if I still have negative 15 on top, but this time it's only a y, over negative 3y to the 3rd power. So again, negative 15 over negative 3 will give me a 5. And that 5 got to be 5 over 1, so that means that 5 is on top. But this time I got 1y on the top, 3 of them in the bottom being multiplied. So when they cancel out, or when we subtract the exponent, then I should have 2 of them left in the bottom. So my answer will simply be 5 over y squared. Okay? So we will do some example like this in the next couple lecture video. Once I finish and introduce the power rules, we will begin to simplify a little bit bigger problems. All right, that will conclude this lecture video. Thank you for watching.